I don't see them fading away. I think there'll continue to be refinements and advancements. But I think what the industry is trying to do now, and Agilent's been a good example of it, they're trying to, at one point they were trying to make top-of-the-line instruments. Who made the biggest NMR? Who made the biggest mass spec? Who had the most grandiose equipment in the marketplace? I think now they're looking a step back from that. They're looking at the lower end more because there are industries that can't afford that type of equipment, and also they don't have the need for that much expertise. A good example is in the food industry and the environmental industry. Food now has new regulations in place regarding testing of food products and functional foods and ingredients in food. And they need to do more and more testing, but their testing is more rapid, repetitive testing. It's not like pharmaceutical or biologics testing or drug discovery type work. So they need more rugged instruments that are fast in terms of turnaround time, can provide more productivity in the lab, more throughput in the lab. And environmental is the same way. We're doing analysis of water and pollutants in water, things like that. It's not very intricate work, but it's very high level in terms of the amount of testing required, lots of samples to test. Agilent came out with two new instruments over the last year or so, one in the LC side and the other on the GC side. One is called the Intuvo, which is a gas chromatograph unit, which is totally different in design. But the focus on it, it's a low-cost instrument that gives you very fast, it's very easy to use, very small instrument, but get very quick results, very fast turnaround, a very rugged instrument. And then they came out with something called the Ultivo, which is an LC interface to a mass spec, a small system, but again, giving you data very quickly and very easy to use for these types of industries like food and environmental, where there's not a high level of expertise, but they need to get results quickly and good results. And I think the industry is looking now at more like low-cost instruments that are small but easy to operate, so anyone can run them practically, but also giving you good data and be able to give you a lot of data in a short amount of time. So rather than going to getting more and more, research-grade technology, which they'll always need, they're looking more on the lower end in terms of being able to sell more instruments at a lower cost, but and getting faster turnaround in terms of results and information back to the laboratory.
So then, if we look at it from a biopharma perspective, is that something you think could afford to happen there, or is the potential cost of failure too high, and the need for clarity so high there?
Right. I think that's just it. I think in many instances it's kind of hard to sell instruments when they're $500,000 each, or if you can sell them, you can only sell one or maybe two. This way, you sell more smaller instruments, $40,000, $50,000 range, but maybe you could sell 3 or 4 at a time. And labs are starting to do that. I'm starting to see laboratories order 4 or 5 gas chromatographs or 3 or 4 liquid chromatographs, but buying them more in bunches, but being able to use them in series, like to generate a lot of data and get it very quickly and get it very economically, rather than sending all these samples out to an outside lab and paying a lot of money. Bring them in-house and test them with these types of instruments, and the cost per analysis will drop quite a bit and still give you very good data and results.
So just to clarify that, you feel that is a trend within biopharma, that there's a shift towards the sort of the lower cost but higher throughput instruments?
Yeah, I think for most laboratories that's the direction. I think, unless you're really in a very sophisticated drug discovery lab where you need to have the top of the line in every instrument to get very superior results. Most labs don't operate that way, and I think for the bulk of the labs, they're looking for faster results, faster turnaround, and ease of use, and also instruments that can sort of repair themselves, like instruments that don't break down that often, and when they do, you know what the problem is and get it fixed right away. So not very sophisticated in that regard, but have a high uptime that they very rarely break down. I think that's what laboratories want to see.